first video in the statistics topic of the Specialist Maths course. This is going to take the knowledge that you learned for methods and just going to extend on it slightly. Okay, so we're going to look at linear combinations of random variables. So that's where we have simply more than one random variable happening at a time. And so we know that x is usually one of the random variables. Well, we could also have y as another of the random variables. And if we express y as a function of x, so we can say y equals ax plus b, then that actually leads to these rules just here for the expected value and the variance. And they can be used quite nicely. So I'm not going to go into the proof for these, but if you're interested, I think that your textbook will show you what that proof is. So we're just going to jump into some examples here and use them to help us here. So we know that x is a random variable with an expected value of 14 and variance of 3. So to find the expected value of 3x minus 2, that is some other function of x, so we could call it the expected value of y, then e of 3x minus 2, just following the rule above, is going to be 3 times the expected value of x and then minus 2. So subbing in e of x there, I know e of x is just 14 from the question, minus 2. So 3 14 is going to be 42, minus 2 leaves us with 40. And as for the variance of 5 minus 4x, now again we'll use the rule just up above. So a in this case is the number in front of the x, so that's going to be our negative 4. So we're going to have negative 4 squared times the variance of x. And we know the variance of x is just 3, so that's going to be 16 times 3, which is 48. And that's all there is to it. Now, we have this next part, and this is going to help us to develop a couple of other rules. So I made the question a little bit nicer because I just didn't want to draw like massive tables and stuff. So I've just got 2 tetrahedral dice. So that's a 4-sided dice. And so we have x1 is the number observed on the first die and x2 is the number observed on the second. So what I want to do here is find the expected value of x1 plus x2 and also the variance of x1 plus x2. So x1 plus x2 just means that we're adding the result from those 2 dice. Okay, so I'm going to draw a quick 2-way table so we can see what's going on. So we can have 1, 2, 3 or 4 on either of the dice. And when we're adding those together, we're going to end up with 2, 3, 4, 5, and then 3, 4, 5, and 6, 4, 5, 6, and 7, and 5, 6, 7, and 8. So I can create a probability distribution table here. So if I go x1 plus x2, and their associated probabilities. So to write this, I'm just going to call this x, and so I can say then the probability that x equals x. So when I draw this, my options are 2, 3, 4, 5, 6, 7, and 8. And the probabilities is just going to be 1/16, 2/16, 3/16, 4/16, and then going back down again. Yep, so that all adds up to 1, so we're all good. Now, to do the expected value of x1 plus x2, we're going to use the rule that we had in methods. And so we're going to do 2 times 1/16 plus 3 times 2/16 and then plus 4 times 3/16 plus 5 times 4/16 plus 6 times 3/16 plus 7 times 2/16 and then plus 8 times 1/16. Apologies if this stuff's up, my screen's just going nuts at the moment. So, now I'm just going to use the calculator there, so just bear with me for a second. So we end up with 80 on 16, which just simplifies to 5. So that's the first part of it. That's the expected value, and you can see that right here. I mean, 5 is the most common result, so it is what we would probably expect. As for the variance, well, that's going to be the expected value of x1 plus x2 squared, and then we're going to subtract the expected value of x1 plus x2 squared. So to work out this part of the equation here, well, I just need to square my answer from there. So that's going to be fine. That'll be really easy to do. But this other part of it just here, in order to do that, I need to have the x squared row on the table. So that's going to give us 4, 9, 16, 25, 36, 49, and 64. And then I'll do the expected value with that row instead. I'm just going to do that quickly on my calculator. So this first part here, using the calculator, worked out to be 27.5. And then I'm going to subtract 5 squared. So I end up with just 2.5 for the variance. So the interesting thing here is that we can very easily figure out what the expected value and the variance are for each of these random variables independently. So if I just consider x1, which will be the same as x2, then the possible outcomes is going to be 1, 2, 3, and 4, with a probability of 1/4 in each case. Again, my apologies, my screen's just stuffing up. So, the thing here is that to do the expected value, well, we're going to have 3, 6, 10 over 4. So the expected value of x1 is 10 over 4, which is 5 on 2. And that would be the same for x2. And so if we have 5 on 2 plus 5 on 2, well, we get, again, this result just here of 5. So we can generalize this and say that the expected value of x1 plus x2 is going to be equal to the expected value of x1 plus the expected value of x2. And this is actually going to be true for okay. I'm going to just try and finish this up because my screen's really playing up. So the thing is that e of x1 plus e of x2, or just separating like that, that can be done for any random variable x. Okay, so using the expected value works fine every single time. The variance, on the other hand, now you're going to just have to take my word that the variance of x1, which is equal to the variance of x2, is going to be 1.25. Okay, you can very easily confirm that for yourself. However, we can see then that this number here is just going to be the variance of x1 plus the variance of x2. And so we can say that the variance of x1 plus x2 is equal to the variance of x1 plus the variance of x2. However, this is for independent events only. Okay, so that's the two different situations that we can consider there. So finally, what we can do is we can combine these two rules. So if we want to do the expected value of some random variable x, which is being multiplied by a constant a, and then plus another random variable which is also being multiplied by a constant, then we can separate that into e of ax plus e of by, which then can be separated further using the rule that we looked at the beginning. We can just make this a times e of x and b times e of y. Whoops. Didn't need a bracket there. So this here is what we really want to be able to use. And we can do the same thing for the variance. So if we have the variance of ax plus by, then we can make that the variance of ax plus the variance of by, which, using our rule from earlier, can become a squared times the variance of x plus b squared times the variance of y. But again, this is for independent events only. Okay? Anyway, I'm going to leave that video there. So we'll see you in the next one.